Hello everyone. Today I'm excited to present our paper, Quantifying and Narrowing the Unknown, Interactive Text to Video Retrieval via Uncertainty Minimization. In this talk, I'll introduce a new interactive framework designed to intelligently resolve the fundamental challenge of uncertainty in video search. Text to Video Retrieval, or TVR, aims to find relevant videos from a text query. Ideally, a search for people playing a football game returns a perfect match, as shown in the red box. However, this is often difficult due to the uncertainty phenomenon. A vague query like connecting something to system can confuse the model, leading it to retrieve the wrong video because it fails to grasp the user's specific intent. This is the core problem we are solving. We've identified three distinct types of uncertainty. First is text ambiguity, where the query itself is vague, using words like something or generic phrases like cartoon play for kids. Second is mapping uncertainty, where a clear query like two guys are wrestling could plausibly match multiple videos in the database. Finally, we have frame uncertainty, where visual noise, like motion blur or occlusion, corrupts the video data and misleads the model. Interaction is the best way to resolve this, but current methods, whether heuristic or ad hoc, share a critical gap. They don't explicitly quantify the uncertainty. They ask questions, but don't know why the retrieval is failing. Our work diagnoses the specific uncertainty to target the interaction. So, our solution is the Uncertainty Minimizing Interactive TVR Framework, or UMIVR. This page gives you a high-level look at how it works. On the left, you see the interactive dialogue. A user starts with a vague query like cartoon play for kids. On the right, you see what's happening internally. Our system immediately detects high text ambiguity. It then asks a clarifying question. After the user provides more detail, the system's uncertainty decreases, but now it detects mapping uncertainty. It asks another more specific question, and after the final response, all uncertainties are resolved, leading to the correct video. This is the core idea, a system that actively diagnoses and treats uncertainty in each round. To enable this, we introduce three components. To measure textual vagueness, we propose the Text Ambiguity Score, based on semantic entropy. A vague query will match many different video descriptions, resulting in a high TAS. To quantify model confusion among top results, we use the Mapping Uncertainty Score, which measures how far the ranking deviates from an ideal confident result via JS divergence. Finally, to mitigate visual noise, our Temporal Quality-based Frame Sampler intelligently selects only the sharpest, most informative frames for the model to analyze. We integrate these scores into the UMIVR interactive pipeline. It's a closed-loop system that starts by computing the TAS and MUS for a user's query. This leads to the core of our framework, adaptive question generation. If TAS is high, the system asks a broad, open-ended question. If MUS is high, it asks a targeted question to distinguish between similar-looking videos. The user's answer refines the query, and the process repeats, progressively reducing uncertainty until the correct video is found. To implement this efficiently, we built our entire framework on a single unified architecture, Video Lave. This powerful model handles all of our system's tasks, from retrieval and captioning to question answering. This unified design is far more efficient than prior multi-model approaches, as it significantly reduces memory usage and latency while also avoiding complex integration issues. To validate our work, we compared UMIVR against strong baselines from IVR. We re-implemented them on our own architecture to ensure a fair comparison, guaranteeing that performance gains come directly from our uncertainty minimizing strategy. Our results are clear. On MSR-VTT, our method, the orange line, consistently outperforms all baselines in both accuracy and efficiency. This strong performance also generalizes to the MSVD and ActivityNet datasets, confirming that minimizing uncertainty is a broadly effective strategy. Here's a final example. A user query, person playing a game, starts with a terrible rank of 324. UMIVR first asks a question to reduce text ambiguity, improving the rank. It then detects mapping uncertainty and asks a distinguishing question, which finally brings the correct video to rank 1. This shows how our adaptive strategy works step by step. To conclude, our work makes 3 key contributions. First, we identified and defined 3 fundamental uncertainties in TVR. Second, we introduced UMIVR, a principled framework to explicitly quantify and minimize them. And finally, our uncertainty-driven approach sets a new state of the art, leading to more accurate and efficient interactive video retrieval. Thank you for your listening.